Hi, I am Dr. C. Christy, Assistant Professor from Computer Science Department, St.Joseph's College of Arts and Science, Autonomous, Cuddalore 1. This video, let us see about white box testing. Introduction. Software testing is critical element of software quality assurance. Software must be tested to uncover as many as errors before delivered to customer. Perspective of software testing. Software is tested in two perspectives. One is white box testing, the another one is black box testing. White box testing is used to check the internal logic of software component. In black box testing, software requirements are tested. White box testing. It tests procedures in detail. It tests and ensures that all the conditions and statements are being executed at least once in loop. It is also known as glass box testing. Test cases. It tests all the independent paths are within a module that have been tested at least once. Test all the logical decision on the true and false sides. Test all loops at their boundaries and within their operational bound. Test internal data structures to ensure their validity. Objective of white box testing. Logic errors and incorrect assumptions are inversely proportional to a path's execution property. A logical path is not likely to be executed. It may be executed on a regular basis. Typographical errors are random. Untested paths will contain. Working process of white box testing. It consists of the following steps: input, process, proper test planning, and output. In input, requirements, functional specifications, design documents, source codes are considered. Processing is used to perform risk analysis for guiding through the entire process. Proper test planning. Designing test cases so as to cover the entire code. Execute, rinse, repeat until error-free software is reached. Also, the results are communicated. Output. Preparing final report for the entire testing process. The first one is basic path testing. It is white box testing. This test to execute every statement in the program at least one time during testing. Basic set is the set of all the execution path of a procedure. It contains the following steps: flow graph notation, cyclomatic complexity, and deriving test case. Flow graph notation. The following individual constructs combine together to produce the flow graph for a particular procedure. This is for sequence, this is flow for until, this is for if, this is for while construct, and this flow is for case structure. Basic terminology associated with the flow graph. Node, edge, region, and cyclomatic complexity are the terms used with flow graph notations. Node. It represents one or more procedural statements. Each node contains a condition is called a predicate node. The edges between nodes represent flow of control. The region in a flow graph is an area bounded by edges and nodes. Cyclomatic complexity. It provides the number of execution in independent paths. It provides a upper bound for number of tests. For each independent path, a test should be conducted to see if it is actually reaching the endpoint of the procedure or not. Cyclomatic complexity. It determines the number of region of flow chart corresponds to cyclomatic complexity. V of G, that is the definition of graph. A graph consists of a set of vertices and edges. V of G equal to A minus N plus 2, where A is the number of flow graph edges, N is the number of flow graph nodes. V of G equal to P plus 1, where P is the number of predicate node. Deriving test case. The process of deriving test cases consists of following steps. First step, form a design or source code, derive a flow graph. Second step, determine the cyclomatic complexity V of G. Even without a flow graph, V of G can be determined by counting the number of conditional statements in the code and adding one to it. Third step, prepare test cases that will force execution of each path in the basis set. Each test case is executed and compared to the expected results. Second one is graph matrices. A graph matrix is a square matrix whose size is equal to the number of nodes on a flow graph. Each row and column corresponds to an identified node and matrix entries correspond to connection between nodes. That is, connection between nodes is called edges. By adding a link weight to each matrix entry, the graph matrix can become a powerful tool for evaluating program control structure during testing. Third one is control structure testing. Control structure testing is used to increase the coverage area by testing various control structures present in the program. It consists of following types: conditional testing, data flow testing, and loop testing. Condition testing. It ensures that the logical condition and decision statements are free from errors. Examples of conditional testing: relational expression. Expression 1, operator, that is the relational operator, and expression 2. The relational operator may be less than, greater than, and or any operator. Simple condition, not operator. Expression 1, compound condition. So two or more conditions or expressions are combined and produce the condition is called compound condition. Here expression E1 and operator, expression E2. This is one type of expression condition. Expression E2 and operator, expression E3. This is another condition. So these two conditions are combined through or operator E1 and operator E2. This is one condition. E2 expression and operator E3 expression. This is another condition. These two conditions are combined through, checked through or operator. Boolean expression and or not. Example A expression or operator B. Data flow testing. Data flow test method chooses the test path of a program based on the locations of the definition and uses all the variables in the program. Loop testing. It is defined as a software testing type that completely focuses on the validity of the loop constructs. This consists of following four types: simple loop testing, nested loop testing, concatenated loop testing, and structured loop testing. Simple loop testing. This test is applied to loop bodies which contain no other loops. Nested loop testing. It is applied when at least one loop is nested inside another. Concatenated loop testing. It is applied to the loops that have been concatenated. In the concatenated loops, if two loops are independent of each other, then they are tested using simple loops, or else test them as nested loops. Structured loop testing. It is a form of software testing that focuses only on the correctness of the loop structures. It is the component of control structure testing. So this is the diagram for simple loop, nested loop construct, concatenated loops, and unstructured loops. Thank you.